Okay, great. So welcome again, everybody. Thank you for joining the webinar. But I would like to first check with you that the sound is okay for so my microphone and both the two speakers of the day microphone are okay, and that you can hear us, all of us, well. So if you can just confirm in the chat box, that would be great. Okay, cool. Thank you. So welcome again. So today the objective is really to present a topic. I think that we didn't talk too much for now until now within the ecosystem. So it's about IoT, using IoT with blockchain to enable new use cases around insurance. So basically, we'll try to share to split the presentation into two main topics. So we'll start with Laurent Souillet, which is the IoT agency director in the Sigfox for the Sigfox operator in the US. So he will share with you what is the value of combining the Sigfox and blockchain to enable this kind of use cases. So he will give you more details about the La Parisienne Assurance, which is what was a very interesting and relevant use case for scooter tracking in France. And in the second hand, Axel, who is a solution success manager in Europe, will give you more details about the tutorial he uploaded he shared on LinkedIn for about how to set it up technically, basically. So how to link Sigfox to smart contracts using Microsoft Azure IoT Hub. So, and don't forget, for those of you who are not familiar with this kind of conferences, webinars, that you can ask your question anytime in the question section. So at the end, we'll have a 15-minute session to ask the question, and you can directly get the answer from both speakers. So thank you again, and thank you, Laurent and Axel, for taking the time today to present this interesting topic. So I will let you, Laurent, start with the Parisienne Assurance business case.
Okay, so first of all, a short presentation of La Parisienne Assurance. So La Parisienne Assurance is, they call it full stack digital insurer. They deliver their products through APIs. What they do is they provide solution for insurers, brokers, insurtech, many different players, physical retailers, around what they call P&C, that's personal and casualty lines, which are insurance you have for your car, for yourself if you own someone. They are currently present mostly in Europe, very growth of revenue per year, and they have more than 200 partnerships currently. So the idea with La Parisienne and Sigfox was to create the first usage-based insurance using connected objects. You may already know what usage-based insurance is. Maybe for some of you, you can already have an insurance for your car by the mile most of the time. It's really highly depending on what you say to your insurance, how many miles you have done during the year, and most of the time it's capped. What La Parisienne and Sigfox wanted to do is to have something more connected, more accurate, so that you can not rent, but be insured every time you drive your car, and you pay per the hour of the use of the car. So that's why they needed to have data on when the vehicle is starting and when it's stopping, so that they know when they need to insure. So this is, for the next slide, the exact use case. Even if you see a car, is they started with scooters, and it's a way to fit with the current trends in urban mobility. You know that your rent, most of the time, the means of mobility, the car and the scooters, you don't use them so much, so insuring it most of the time for nothing is not worthy. And the trend is really moving into having a a pay per usage. So you pay only for what you use. So what they have deployed, and because insurance is highly dependent on responsibility, they decided to use a blockchain as a way to ensure that the contract starts and that the responsibility is given to the La Parisienne to insure the asset and the person. And when it stops, that this responsibility is not anymore in action. So there is a sensor that is inside the scooter. It sends an information of beginning of movement using Sigfox, and all the movement, not all the information about the beginning and all the end are tracked using blockchain, creating an ephemeral insurance smart contract automated by the blockchain. And that way they can have some very easy, lightweight transactions. Maybe some of you know the insurance business model. It's highly relying on lots of contracts, lots of verifications, lots of processes behind. And the fact that La Parisienne is very oriented into the digital products and very agile, using the blockchain enable them with very low cost of transaction when it comes to say this contract started, this contract stopped. Those kind of processes are very complicated for classical insurances because they rely on very strong and very resilient infrastructure, but very heavy and not that reactive. So that's why the blockchain and the full digital player are really making sense in providing those smart contracts. Maybe the next slide. Yes. So how does it work concretely? I almost said the way it's working. So what you have when you start your scooter is that you have the app of La Parisienne that tells you your contract is starting as soon as the scooter is started its movement. Please don't use your smartphone while driving, but anyway. You have the real data is sent through Sigfox, and at the end of the journey, the user receives a message indicating how much time he drove and how much it cost him to drive this scooter in a very insured way, meaning being covered by La Parisienne. So the idea behind is with IoT, you have the ability to have real data about what is happening around your assets, and that's a very valuable information for all the insurances. Some of you may know the way the insurances are working is highly dependent on not preventing a risk, because you can't prevent a risk to happen, but it's about evaluating how much risk is likely to happen and how much it will cost. So basically, in the past, it was highly relying on statistics. Given what you faced the previous year, you will be able to understand how bad or how good the next year could be and how much you should have to pay. This type of usage is really eased by the IoT, because you get real data, real time, that give you insights about the risk and the usage of your assets. And that way you have a better understanding on how you can evaluate the cost of the risk. So this is for the IoT on the first part. On the second part, the blockchain enables what we have seen before, is having smart contracts, having some ideas about the responsibility of who was in charge, for instance, of the asset at the time where the event happened. So all those information that are really important in the insurance domain, meaning risk assessment and traceability, they are really improved by the combination of the IoT and Sigfox. So it's not only user consumer based on the smart insurance, but it can be extended to lots of things that, let's say, for instance, when we deal about container tracking, when you are sending goods all across the world, like some of our customers for Michelin, for instance, sending tires from France to the US, it involves roughly 30 partners, and there are around 200 interactions during the journey of the container. At each time, a partner should be the driving company, the truck company, or the customs, or the shipping company, or the train company, the way they load the container on the trains. You have some new actors and some risk around that. It means that for sending the container, Michelin contracts an insurance. If they are able to give more insight to the insurance company about where the asset is and who is responsible for the asset at the time where some events happen, then they could lower the cost of the insurance. And all of this require identifying responsibilities, and it's really the domain where the blockchain is really important. So as a conclusion, that's why La Parisienne sees a lot of opportunities in IoT and blockchain, because that's a way to deploy new way of doing insurance in the coming years.
Thank you, Laurent, for this introduction about really the how valuable it is to integrate Sigfox like IoT, using IoT combined with blockchain. So I think now it's interesting. Axel, if you want to move forward and go over the technical integration, if possible. Thanks.
Thank you, Nicolas, and thanks, Laurent. So yeah, as we've seen, some projects are already live using the blockchain. So here I will present kind of an implementation example that you guys would be able to do by yourself using a Sigfox device and Microsoft Azure. If you can go on the next slide, please, Nicolas.
Sorry, Axel, I think we cannot hear you anymore.
Then now, can you hear me?
Yeah, now it's better.
Okay, so shall I restart?
Yes, please. Sorry about that. We are all, everybody from home, so sometimes the connection has a bad effect on the microphone.
No problem. Just saying that we've seen that some projects are already live using the blockchain, and especially the one with La Parisienne Assurance. I will be presenting now an implementation example using a Sigfox Sensit device and Microsoft Azure. So you can please jump on the next slide. So to recap, I wanted to present an overview of a Sigfox message to understand why basically it can be interesting to store the data coming from an IoT device into a blockchain. So as a recap, it's always the same schema. We have the Sigfox enabled object that will be sending some readings through the radio interface that will be picked up by some Sigfox base stations. Those base stations will then push this information up to the Sigfox cloud. And this cloud will then push again this information up to the IoT platform that has been configured with. So here we are talking about storing the data coming from those objects into an end platform, kind of customer platform with a blockchain. Please, next slide. So I wanted here to recap on the main blockchain principles. So basically, what is a blockchain? It's simply a series of blocks that hold some information and that are distributed across a network of nodes. So basically, each of those nodes holds a local copy of the blockchain and will be updating this copy through the lifetime of the chain. And then the second duty of the node is to verify incoming new blocks to append them on top of the chain. So when you decide to store the information in that way, it's pretty easy to understand that the blockchain becomes kind of a distributed ledger of information. Basically, the information will be stored into each block, and the blockchain is kind of a replacement of a database, for example. That way, it's a new way of storing the data, but also to exchange the data, because then you can define specific rules on who will be able to interact with the blockchain or see what is inside the blockchain, and so on and so forth. So the three keywords I wanted to mention here is first immutability, because since it's a chain of blocks, the only action you can do is basically append a new block at the end of the chain. Thus, there is no way to edit a previous block or remove a previous block. So you don't have any way to basically erase the data into the chain. That's why once some data is pushed into the blockchain, there is no way to remove it. Second one is security, because as we will see after, the who can access the chain is very important, but once it's defined, there is no way to mess with this, and only allowed users will be able to publish into the chain. And the last one is transparency, because if you allow people or users to check what's inside the blockchain, it will be fully transparent, meaning they will be able to see everything that has been happening since the beginning of the chain. So I wanted very quickly to define the two types of blockchain available today. The most known ones are the public ones, for example, known for cryptocurrencies, let's say Bitcoin, for example. Those ones are what we call permissionless blockchain, which means anybody can ask for publish and to participate to this blockchain. The way we will say if someone can publish into it will be based on the consensus that has been chosen for this blockchain. For example, we know the proof of work that miners are using for verifying new blocks of the Bitcoin blockchain. Those public blockchain are fully decentralized because there is no authority that is kind of mastering the chain. But of course, this is low efficiency because the trustability is kind of shared among all the nodes of the chain, which are anonymous different entities. So the performance is lower. In our example, just after, we will talk about a private blockchain. So those are the one with permission. So most of the time, private blockchain rely on using users and role administration tools to identify which user can publish into the chain and what rights they allow to those users. Next slide, please. Once we know what is a blockchain, okay, we understood it's a new way to store and exchange the information. We then jump into the smart contract parts. So a smart contract is just a set of predefined actions that will be triggered based on what data is actually processed into the blockchain. So it's actually a way to interact with the data that is flowing into the chain. And that is what gives the full power of the blockchain, because it will allow to create many new usage, I would say. I put here Solidity file because, so what is Solidity? Solidity is a language to write smart contracts. So, and why it's interesting, it's because it has been created to be able to define whatever situation in a smart contract. We call it, it's a complete Turing language. And this is basically a framework for a blockchain developer to start creating application based on smart contracts. Then, so once you create your smart contract, you understand that this will automatically trigger actions based on what is coming into your chain. And so, as Laurent said before, that will basically allow to get rid of any administrative operations. He told us, like, in insurance company businesses, you have so many administrative and contract related processes that are super heavy. For example, that would be a way to get rid of this. We've seen some use cases in the airlines industry that have the same characteristics, I would say. Next slide, please. So here we go. We arrived here where I wanted to explain the example I've done with Microsoft Azure. So I've created, so the context is the following. We have a pharmaceutical company that I called Vital Pharma that is basically manufacturing pharmaceutical products, let's say vaccines, for example. And then you have a company that is specialized in the shipment and the delivery of those products, which is called deliver.it. And then you have pharmacists that are about to receive those products, let's say, for example, across the whole Europe. As Laurent was saying, that is the most easiest setup for such process, meaning that could be much more complex. Let's say if you have other intermediaries, you could have multimodal transport, you could have intercontinental shipments, which would involve, I don't know, planes, boats, or many other intermediaries. So that is the most basic setup. But then we see that this kind of setup, even this one, requires multi-party processes, so multi-companies are involved, and those products requires to be monitored, meaning, for example, they need to be in a certain range of temperature. You cannot, for example, ship a vaccines over, I don't know, a certain level of temperature or humidity. It requires transparency because the pharmacist needs to know where the products are, when they will arrive. And I haven't written it here, but it requires also traceability because we need to know who and when has received a certain pharmaceutical product to be able to optimize where we want to ship it. So what would be the associated solution to such problem? That would be a blockchain storing incoming data from the delivery of such products inside the blockchain with an associated smart contract that would trigger some actions based on those data. In our example, I've created a smart contract which is called refrigerated transportation, and that is basically monitoring the temperature and humidity values sent by the Sigfox device. And if those measurements, those readings are outside a certain range of acceptable data, then it will automatically, for example, ask for a refund, for example, from Joe Blogs or Vital Pharma to deliver IT, or even alerts. And then on the left here, you have the recap of the architecture. So we see that the Sensit is pushing the data to the Sigfox LP1 cloud. That is then pushing it to Azure, and then inside Azure you have a couple of things that are done. First, of course, the data is formatted, which means it needs to be parsed. Okay, the Sensit is sending hexadecimal values, so we need then to be able to understand what are those values. Once it's parsed, it's pushed into a blockchain as a service block, which is provided by Microsoft to ease the development of blockchain projects. It's also stored into a simple storage entity. Just it's not required, but it's to have a second way to store the data. And then finally, it's then made available through applications such as a web application. We'll see on the slide after. So please, Nicola, if you can. Thank you. So this is the detailed architecture. I won't spend too much time on it. Just if I go quickly over each entity. So we start with an IoT hub inside Azure. Then the data is pushed into a function app, which is responsible to parse the information. Then into a bus that will push it into a logic app that will be formatting the data. This data will be pushed to another bus, service bus. At the output of this bus, you will have two consumer services. The first one will be listening for what's incoming in the bus and will push it to the transaction builder that will make from this data transactions that are available to be ingested by the Azure blockchain service right after. But the most important part to me in this schema is the top, because you can see you have a web application as well as a smartphone application that will be able to connect basically to the system, and that will allow users to interact with what has been pushed into the chain and basically interact with the related smart contract. On the right of those apps, you have the famous Azure Active Directory entity that is responsible to define and store all the role and identities of the users. Next slide, please. And this is the results. So those are some screenshots from the web application that can be that I was just mentioning before. So when you jump on the web application, you will be asked to create a contract. So on the left side, I've put a screenshot. The device is the Sensit. The owner of the contract is Joe Bloggs. It's the name of the pharmacist, for example. The observer is Vital Pharma, the company that is shipping the product. And then you define your rules. So, okay, mine humidity will be 25, max will be 75, and so on and so forth. On the right side, you get like you can see the screenshot of the dashboards once the smart contract have been created. And then each and every counterparty can log in this web application and transfer the responsibility of the shipment. For example, the shipment company called deliver.it can log in and say, okay, I've just got the products and I'm now responsible for it. This will be stored inside the blockchain as well. And these steps will go back to back until the end and the completeness of the shipment. So if everything goes well, at the end of the day, the pharmacists log in the portal and say, okay, I've received correctly the product, the shipment, and it's okay. And then the smart contract shifts into the completed state. Everything is okay. Now, I think we can jump into the next slide, please. And this is the slide where we have a problem. Basically, you have the Sensit that has sent an out of compliance measurement. For example, let's say it has sent a temperature reading of, here it's 19 degrees, which is too high from what has been configured into the smart contract. At this point, what will happen is that this information will be stored into a block into the chain, and nobody will be able to remove it ever. The contract will shift into a special state, which is the out of compliance one. Again, nobody will be able to edit this. And then based on what has been decided in the smart contract, any actions can be undertaken. The first one is to raise an alert. We have here a screenshot of an email, for example, that can be sent upon the reception of or upon the shift of such contract. you can imagine that this kind of issue can, for example, issue a refund for the related counterparties. For example, we can imagine that the shipment company will be asked to refund Vital Pharma, for example. You can imagine such a mechanism in retail. For example, let's say a company that is shipping some fruits or vegetables and want to be insured against the fact that those products will arrive in good conditions. So that allows many use cases, as we've seen, and I hope this one can make sense, and you can, by the way, access this tutorial on GitHub and on LinkedIn. I think if we go on to the next slide, please, Nicola, you will be able to see the following links. I think that's it for me, Nicola.
Thanks a lot, Axel. So yes, we'll share with you the slides on Friday. So we'll make, of course, a follow-up email, and we'll upload the video on YouTube. So you can visit the different links if you want to know more about the Parisienne use case article, the LinkedIn article from Axel, or just take a look at the GitHub repository. So again, thank you to both of you. So we have a couple of questions. The first one is about the Parisienne business case. So someone is asking if it's a live project and in France for both, so for the scooter tracking use case and for the car one.
Yeah, the one for the scooter is live. I could try to find. I'm not really. Being US based now, I don't know so much about the recent development on the scooter one, but I'll try to find a place where you can find more details about the offer in case you want to rent a scooter and be insured smartly. Yeah, for sure.
Thanks. Some other question, more technically this time. So how will the blockchain technology influence the necessity of brokers in the future, in your opinion, Axel?
More, can you repeat the end of the question? Sorry, how it will?
How will blockchain technology influence the necessity of brokers in the future? It's more an open question.
Okay.
Know your opinion.
Yeah, I think blockchains won't replace brokers or message brokers that will come associated with. So I'm not sure to understand exactly the question. I think that what can be done in terms of architecture would be to set up a broker or a bus, message broker, let's say, and then to plug the input of the blockchain as one of the consumer of this message broker. So you can decide what kind of data you want to push into your blockchain and and which one you don't. For example, let's say you have an IoT device that is sending different kinds of data. You want to store into your blockchain only a specific related kind of data. So then you will be able to use a message broker to push only the important information into your blockchain. This is how I see it.
Okay, thank you. And another question to know if the platform is based on Ethereum.
Yes, indeed. So that's a good question. The platform is based on Ethereum because that's what comes with the Solidity language. So Ethereum has been developed with this Solidity language in mind. So today Ethereum is the most common, I would say, blockchain type to develop smart contract related applications. So yes, indeed, it's based on Ethereum.
Okay, thank you. So the understanding is that the private blockchain is centralized as opposed to decentralized. Is it correct?
Yes and no, because yes, it is correct in the sense that the public blockchain is always decentralized, because by way it's built. However, the private blockchain can be partially decentralized because, as we've seen, it's a set of nodes that is validating the blocks and storing a replica of the chain. So the information about the blockchain will still be distributed across a network of nodes, and then so it can be decentralized in that way, but it's right to say that when we are talking about private blockchain, of course, we want to manage who is a node, who can validate a block. So most of the time, it's true. It is centralized. Sorry. Yeah.
Okay, thank you. We have many questions, which is a very good thing. We'll try really to ask most of them. We'll see if we run out of time, but I see that this is a topic that people find very interesting. So again, yeah, feel free to share your question, and if we don't have time to go over all of them, we can maybe follow up by email on the question. So we have one question for Laurent. So the question is, which partner has developed the device for the vehicle tracking use case for La Parisienne?
That's a very good question. I knew it before and I've completely forgot the name. I'm really sorry. But basically, it's really based on motion sensors. So whatever device that is able to have a motion sensor, namely an accelerometer, two main complexities to keep in mind. First, accelerometer, defining what is a movement and what is a real movement seems easy, but that could be a challenge. And second topic is you are inside a scooter, you are inside something that could be metallic, let's say vehicles. So the antenna performances, even if it's outdoor, are very important. So I'm so completely sorry to have forgotten the name of the device, but we'll give it to
yes,
Nicolas, and we'll go back to you.
We can we'll look for it and we'll answer by email. Thank you. Yeah. And do you know if this so you said that it was a live project? Do you know if the service is only available in France or in Europe and maybe worldwide, or it should be in a?
So far it's in France, but as I was saying, La Parisienne is providing solutions for insurers all across Europe. So it could be duplicated as soon as the Sigfox coverage is present, which is the case in most of the countries in Europe. It could be deployed anywhere else, for sure.
Thanks. Thank you for the answers. So we go over some of the questions. Maybe we'll take 3 or 4 more. Sorry, because I cannot read all of them. So automatic refunds are quite difficult. Do you have your own tokens which will allow for the transfer of funds? I think it's a question for regarding the technical integration of blockchain.
Okay. Yep. So it's a good question. I have actually never thought about it, but that could be a way to refund. So we could imagine to create a specific token associated to this blockchain, and happen the refund through the exchange of those tokens. That's another subject, but I think it can be done. Yes. Yeah.
Okay, thank you. We have a couple of questions also about security on many aspects. Like the first one is basically the Sigfox cloud. So why should we trust the Sigfox cloud? Do one of you would like to answer this question? Like, what are the security protocols that ensure that enabling blockchain with integrating blockchain with Sigfox through the Sigfox cloud is secure because
I think try to answer. That's a good question because as we said, who can write into the blockchain is a massive right and needs to be secured, of course. In our case, the only entity capable of writing into the chain is the Sigfox cloud, basically, or is coming from Sigfox cloud informations. So this example relies on the fact that what is pushed by Sigfox backend is trustable, basically. So then Sigfox backend needs to trust the devices that are pushing information. So all of this example relies on the I would say the complete security chain through the sending of a message. So starting from the device, sending the message up to a base station, up to the Sigfox backend. So each of those links needs to be secured. So we know that between Sigfox backend and Microsoft Azure, for example, the data is sent over HTTPS to guarantee the security. Between the base station and the Sigfox backend, you have a specific protocol to secure the connection. And then between the device and the antennas from the base station, you also have specific protocol-related securities to guarantee the integrity of the data. So indeed, each and every steps needs to have a specific secure guarantee to make this use case I would say fly. Because if anyone can push data in the blockchain, then it doesn't make any sense anymore.
Okay, thank you very much. I think it gives an overview of the entire architecture regarding the security. And to answer another question, yes, the Sigfox protocol is proprietary. So the answer, we have released last year the specification of the protocol. So how basically the messages are sending, the devices are sending messages. But Sigfox on the, we have not released the protocol on the base station side. But I invite you, if you want really to know more about the payload and how to encrypt your payload from your device to the Sigfox backend, I invite you to visit the build platform, build.sigfox.com. You have many content about it. So about the encryption of the payload and about the specification of a device sending Sigfox messages. So maybe we can take one last question and we'll try to go over the last one during the follow-up email. Let me 1 second. How blockchain secures the database in this case? The data is saved in the SQL database or directly in the blockchain?
Mm-hmm. It can be both. For simplicity, we can decide to store the data also in a SQL database. That is what has been done. You can also decide to put some watchers onto the Microsoft Azure blockchain to see what's going on in the chain. So you have different possibilities to watch your data, basically. However, it's not. I wouldn't say it's more. Maybe it's more secure because of two things. First, because there is no way to remove the data from the chain. You can. The blockchain is known to be append only, so it means you can only add a block to the end of the chain. Whereas in a standard SQL database, you can always delete some rows and you make disappear the data. So, and the second one is related to the fact that into a blockchain, the data will be distributed on some nodes. this capability can also be done on some SQL database, because most of them now are known to be distributed on several hardwares that can be sharded, that can be, so this can be done on SQL as well. So by default, blockchain is secure in terms of data, because you can only add at the ends of data. For the other capability, both of the mechanism are as performant, I would say.
Okay, thank you very much, Axel, and thank you, Laurent, again for your presentation. It was very interesting. So again, the slides will be shared with you maybe on Friday or next week, and we'll also try to upload the video on YouTube as soon as possible. So feel free to visit our webinar YouTube playlist, because you will find many other interesting topics. And just to let you know, maybe last point, next week we'll have another session, this time about AI. So how to embed some intelligence on your device, on the module side, and not on the cloud. So it's also very interesting. We will try to, with Cartesian, which is a partner really recognized in this area, they will try to share with you the value proposition of why embedding some intelligence to enable an AI use case on your device, on your module, instead of on the server side. So thanks again, and I enjoy your end of the day, and hope see you next week.
Thanks,
Bye.
Nicolas.
Thanks.
Goodbye.
Thanks.
Have a
Bye
good
bye.
day.